Steve Bergen, and in this lesson, let us make our own fractal. And a fractal is a geometric shape that then creates smaller geometric shapes, and each one is similar to the big one. So you may see, as I trace my mouse cursor there, a capital Y. And then, if you see over here, there's another capital Y sideways. And then there's another one that's a little smaller, but it's proportional, and it's sideways. And then there's another one smaller and smaller. And this is all just a composition of capital Y's woven together by a pattern, and the pattern uses logic called recursion. And in this recursion, it goes forward, turns 45 degrees, and then rather than coming back and finishing up the capital Y, it doesn't do that till later. In the middle of doing the very first Y, when it gets to the top of the left branch, it says, whoops, I'm now going to do another Y that's proportional but a little smaller. So it goes to do that Y. But it never actually does it all, because in the middle of it, it says, I'm going to do another one. So it keeps interrupting itself, doing a smaller and smaller and smaller capital Y until it gets to an if statement when it's too small. Okay, let's take a look at a few other famous fractals. This is a tree fractal. The next fractal coming up here, right, in this little slideshow, is a definition of fractal, and the key word is self-similar patterns. There's your tree fractal again. This is called a Mandelbrot set. It's a fraction of circles and boundaries. Here's a triangle fraction called a Sierpinski triangle. And now you'll see in Scratch how it's making the fractal. Notice it never finished that other one until it got to the last branch. So our goal here is to teach you how to make this kind of program. Teach you how to make your own fractal. It requires, of course, knowing how to make a block, which you do at this point in the course. Okay, let's watch the recursion again. This time, let's do it in slow motion. I will tell you out loud what it's doing as it does the tree. I'm doing a tree of 50. Whoops, I interrupted. I'm doing a tree of 25. 12 and a half. 6 and a quarter. 3 and an eighth. 1 point something. I'm finally under 1. I'll go back to the 3 and an eighth. I'll finish it up. And now I got to do another one of 1 and something. Now I'll go back and finish up that one. I've got to do another one of size 3. Whoops, now I got to do one of size 1.5. Now I'm done with one of size 1.5. I'll go back and finish up the one of size 3. Now I'll go back and I'll do the one of size 6 and a quarter. Now I'll do the one of 3 and an eighth. Now I'll do the one that's 1 and something. So what you see it doing here in slow motion is it's doing a tree of successive sizes. Each one is 50% or 60 or 70% of the previous one. You can get different fractals by varying the percentage. I think this one is set for 70%. But the point is, it never completed down here. It never completed the first capital Y. It never completed the second one. So it went tree 50, tree 25, tree 12 and a quarter, 12 and a half, tree 6 and 0.25, kept interrupting itself so it can draw the next branch that is 50% or 60% or 70% of the previous one. And eventually it fills up with branches. The fractal definition from Wikipedia was self-similar. I hope you can see that the original picture, which is never even done yet, is a capital Y, and then each successive one is another capital Y that is proportional to the original one. And even the very smallest one, which is hard to see, but if you can, it's a baby capital Y, and it's proportional in terms of ratio to the original one. Okay, in the next lesson, we'll actually see how to make the code work.